Alright, so for the first question, we are comparing polynomials. So this is what we want to prove. So for every a and b, such that they're positive real numbers, if a is smaller than or equal to b, then n of a is within the big O of n of b. Okay, so first of all, we're just asked to rewrite this with the big O definition expanded. Okay, so let's do that. So this part remains the same. And then this is the part that's different. So here, we wouldn't add this part, but we would have, instead of G, we would have NA. Instead of F, we have NB. So otherwise, it would be the same. Okay, and then you have it's larger than N naught. Thus, and then, so instead of this, so you have NA smaller than or equal to C times N of B. Okay, so for the second part, we're asked to prove this. The approach to this is just to look at the structure of each portion and do it one at a time. So first you have a universal, and with all universals you let these be arbitrary. Then you have a conditional, and with all conditionals you would assume. So you assume, alright. Then you have an existential, and that means that you need to pick. And at this point, you would just leave this blank. Okay, so after that, you have another universal. Then a conditional. So here you would assume this part. And now you want to show this part, so want to show NA is smaller than or equal to C times N of B. Okay. So we take a look at what we have. So from assumption we have this inequality and this one. So we can't really do anything with this, but we can take this one. So we would say, notice from assumption, and we have A is smaller than or equal to B. Okay, so we want this, and then we have a series of things, and then we want to end up with this. That's the plan. So let's see what we can do here. Okay, so first we can raise each of these by the base of n. And this we know to be true since n is larger than or equal to 1. And now we're really close. We just need a C value here. Well, since we know that this is true, all we need to do is set C to be 1. So, if this was 1, then we would know that this is true, or this is true, rather, and we would be able to finish the proof. Since we get to choose C here, we can choose 1. And for N naught, we can choose 1 as well, because that works. And that completes the proof.